let's do a few examples related to what we did last time. So suppose that 40 cars enter a race. How many possible outcomes are there for first, second, and third place in the race? And here we assume that there's no ties. So this is just an example of something, this multiplication principle, right? You can think of determining first, second, and third place as like a process that has 3 steps, where the first step, you choose the car who's going to get first place. There's 40 ways to do that. And then after you've chosen first place, there's going to be 39 ways to choose second place. Right? And then once you've chosen first and second place, there are 38 cars left, so 38 ways to choose third place. Okay, so this is a fairly standard type of question you should be able to solve. But are there any questions about this? Okay, let's do a little bit of a variation of that question. So suppose that a club is electing a president and a vice president. Okay. And also suppose that the number of ways to do this for this particular club is 90. So suppose that there are 90 possible outcomes. How many people are in the club? Okay. Yeah. It is 10, yeah. How do you get, or what's your kind of process? Yeah, exactly. So now 90 is not that big of a number because, I mean, you're right, it's 10 times 9. If this was a much larger number, it might be a little bit more complicated. So just so that you can do this for larger numbers, let me go through a little bit of a process to derive this. But you're absolutely right. You can kind of just see it from this, that it's going to be 9 times 10. So, okay, so let's say, let n be the number of members of the club. So as you were suggesting, if I wanted to pick a president and a vice president, the number of ways to do this is going to be like n times n minus 1. It's the product of 2 numbers that are off by 1, right? So the number of ways to pick a president and vice president is n times n minus 1, right? Because out of a club of size n, there's n ways to choose the president. Once I've chosen the president, assuming the president and the vice president shouldn't be the same person. Hopefully that's clear. So once you've chosen the president, there are n minus 1 people left over to choose for the vice president. So basically, all we're trying to do here is solve the equation n times n minus 1 equals 90. Okay, now this is probably going to bring up some math you saw in high school, right? We can expand this and kind of bring things all to one side. So this will be n squared minus n equals 90. I can bring that to this side. So n squared minus n minus 90 equals 0, right? Quadratic formula, or, I mean, there's lots of different ways you can solve a quadratic, but does anyone remember the quadratic formula? So if this is, if I, you know, if A is 1, B is negative 1, C is negative 90, right? The quadratic formula should be minus B plus minus. So n should be minus B plus minus square root of B squared minus 4AC over 2A, right? So we're getting 1 plus or minus square root of 1 minus 4AC. A is 1, C is negative 90. So plus 360, I think, over 2, which if you put this square root into your calculator, you'll get 19. So it says n is either equal to 10 or negative 9. Obviously, you can't have a club with negative 9 members, right? So this answer is kind of nonsense. So this must be your final answer. Okay. But yeah, in this case, of course, you can just see that 90 is going to be 9 times 10. But if this was a huge number with, like, you know, 5 digits, then you might not be able to see that. So you might want to go through this process. Yeah. I mean, well, in some sense, you could just go through different values. You could look at this equation, go to your calculator, put in n equals 7, see if it's too big or too small, put in n equals 20. You could just find it eventually, right, if you plug in numbers. But that might be, I don't know what's a faster process. I mean, knowing the quadratic formula, this is hopefully something that was quite, yeah, something you've seen in high school and stuff. So I would hope you can do this, but you could just trial and error, yeah. Put in n equals 20, put in n equals 15. You'll get it eventually, right? Yeah. I would say so, yeah. I mean, yeah, I don't think you'll end up in situations where there's more than one answer that makes sense. Yeah. You know, if one of your answers was 3 plus square root 2 or something, you'd also say this doesn't make sense because you can't have that many members in a club, right? I mean, it's got to be an integer, a whole number. Any other questions? Okay. Let me give you a little bit of a trickier one than what we've been doing so far. So Canadian social insurance numbers, I think they've got 9 digits, right? At least that's what I've got in my notes here. So let's just go with it. They have 9 digits. So how many social insurance numbers, like how many possible, I don't mean the actual ones that are used in practice, I mean how many possible social insurance numbers start with a 5 or end with 0, 0. Seems like a very innocent question. But you have to be careful. Let's just, at first, let's forget about this or and just sort of isolate the 2 different parts. So how many start with 5? Any thoughts? So if I know it starts with a 5, how many choices are there for the next number, let's say? It can, let's say, yeah, everything can, all the numbers can repeat, yeah. Technically 10, because we're going to allow, so you have to, yeah, you've got the numbers 1 to 9, and also you have 0, so that gives you 10. Yeah. Exactly, yeah, because we're saying it starts with a 5, so you have no choice for the 5. Like it's kind of 1 choice for the first digit, 10 choices for the second digit, you know, and so on. There's going to be 8 of these. So yeah, it's 10 to the power 8. And then how many end with 0, 0? Yep, and that's similar principle, right? You've got 7 digits with 10 choices each, and then the last 2 digits have, you know, only 1 choice. So 10 to the 7. So at this point, it's really tempting to say that your answer is 10 to the 8 plus 10 to the 7. Right, because we counted how many start with a 5. We counted how many start with a 0, end with a 0, 0. If you want this or that, it seems like you should just add them up, right? Oh, sorry? There's a few different people talking at the same time, but yeah, what's the, oh, sorry? Yeah, exactly. Everything that's in the intersection of these 2 sets is getting counted twice. Right, so if I have the social insurance number 5, let's say 1, 2, 3, 4, 5, 6, 0, 0. Imagine this social insurance number. When we counted this stuff, this was counted because it starts with a 5. When we counted this was also counted because it ends with 0, 0. So if we just add these things, this will get counted twice. So you then have to subtract the number of social insurance numbers that start with a 5 and end in a double 0, which will be 10 to the 6. Okay, so this is your answer. So what we actually use there is the principle of inclusion-exclusion, right? Because if I say A is a set of social insurance numbers that start with 5, and then B is the set of these things that end with 0, 0. The question asked for, like, start with 5 or end with 0, 0, which is the union. So n of A union B by principle of inclusion-exclusion, which I'll just abbreviate with pi. So pi is principle of inclusion-exclusion. This is, the number of elements in the union is the same as n of A plus n of B minus n of A intersect B. Okay, so, right, and this is equal to 10 to the 8, 10 to the 7, minus 10 to the 6. So, okay. So that's, yeah, that's what we, so here we were secretly, we were using principle of inclusion-exclusion. Yeah. So that's, so this is the number, so if we're looking at, let's say, A intersect B, so if we're looking at social insurance numbers that start with a 5 and end with 0, 0, you've got one choice for the first digit, one choice for the last 2 digits, and then everything in between has 10 choices, and the number of things in between is, there's 6 of them, so, yeah. Any questions about that? Okay. So you have to be, if you ever find yourself solving a question that has an or in it, and you are just adding up the different things, you should be very careful that, you know, do those things overlap? Because if they overlap, you need to subtract the overlap. You need, because you're counting it twice. Okay. You could also imagine a much more complicated example where we could say how many start with a 5, end with a 0, 0, or have a 3 in the second digit. Then you'd have an inclusion-exclusion with 3 different sets, and you'd have to use the formula for that, which we talked about 2 classes ago. Okay. Any questions about this? Yeah. In some sense, I kind of, the way we at least discussed this is I sort of came up with this answer, you know, just by reasoning it specifically, but you could have, probably a better way to do it is to recognize that, you know, it is principle of inclusion-exclusion. So, yeah, so the way we use this formula is by setting up, you know, that A is the set of these social insurance numbers and B is this set, and to recognize we're trying to find the union, and then you can always just apply this formula once you know you're finding a union. And then if you can determine this, and this, and this, then you're happy. I don't know if that answers your question or not, but. Right, so it's using this multiplication principle. So if I want to know the size of A, the number of elements of A, how many social insurance numbers start with a 5? There's one choice for the first digit, because it has to be a 5. Then 10 choices for all the other ones. And yeah, if you kind of follow this multiplication principle, that'll be 10 to the power 8, because you multiply for each of the the choices of each digit. So we're kind of layering different topics on top of each other at this point. Yeah. if it was an and, actually what your answer would be this, just this 10 to the 6 here. Because you'd be trying to find the intersection of A and B, which means it starts with a 5 and ends 0, 0, which means you have 6 digits you're choosing, which are the 6 interior ones. So it would actually be easier if it said and, because it would just be 10 to the 6. Any other questions? Yeah? Yeah, definitely on the quizzes, you're going to want to get a final number because that's what the MyLab Math can accept. I think on a test or something, as long as whatever answer you write is like computes the same thing, I think it should be fine. But yeah, for the Pearson system, you should write a number for sure. Any other questions? Oh, yeah. Oh, well, so it would be, I mean, whatever this computes to in your calculator, that would be your final answer for this. Yeah. Yeah, which is going to have, it's going to be a long number with 9 digits or something. Yeah. You should probably memorize them, I think. Yeah. Okay. Okay, so another example. So a palindrome. Some of you might have heard of this before. So it's a word that is the same when written backwards. So, for example, like, so the name Hannah is a standard example, right? If I write this backwards, write it forward, H-A-N-N-A-H, but it's the same backwards. Race car is another famous long palindrome. If you write this forward or backwards, you get the same thing. So a question could be how many, let's say 7-letter palindromes are there? Okay. And they don't have to be real words. So, yeah. So here's a way you can think about this one. We're gonna pick a palindrome. We're gonna count how many ways there are to generate a palindrome. So you can think of that as like a procedure that has 7 steps, right? 1 for each letter. How many choices are there for the first letter? Yeah, 26. I'll just write it like a 26 here. Once I've chosen that letter, so I don't have any restriction about choosing the same letter twice, right? So if I chose C for the first letter, I could choose C for the second letter. It doesn't matter. So I've again got 26 choices. let's say, I mean, I don't see any reason not to have 26 choices on the fourth one. But can anyone see how many choices I have left? Yeah. How come? Yeah, exactly. So when I go to choose this one, it might feel like you've got a lot of choice, but you don't because, these have to be the same in a palindrome. So that's yeah, absolutely right. You've got, that's already chosen. These have to be the same. So I've only got one choice. One choice. So it's going to be 26 to the 4. Which again, if you're doing this on the Pearson system, you should compute the actual number here. Any questions about that? Yeah. I don't know what those calculators can do, but I mean, certainly, if you get it into this step, you can do everything on that calculator because you can do square roots and, but in terms of actually entering the quadratic and asking for the solution, does anyone know if you can do that? Or I'm not familiar with these calculators, to be honest. Okay. But can you just enter the quadratic? I see. So yeah, you'd have to kind of know, what to do. But like I said, if you know that it's going to be an integer number, you can just throw in integers until you get the right answer if you wanted to, right? Okay. So let's move on now to section 5.5. Oh, yeah. That's right, yeah. Although you'll see that this is closely related to some stuff on the quiz, but technically, yeah, we've covered everything you need for the quiz at this point. Okay, so this is on permutations and combinations. Oh, sorry. I don't know. Okay. Permutations and combinations. So a permutation get of a set of objects is a linear arrangement of some of the elements of that set. Okay. This is maybe a bit vague and not completely clear what I mean by this. But basically, all I mean by this is that a permutation is something that you get by taking a set, taking out an element, putting it down, taking out another element, putting it, let's say, to the right of that element, taking another element, and just basically lining up elements of that set. We've already seen some permutations, to be honest. Like when we were talking about this thing with a car race, how many ways are there to pick first place, second place, third place? That's just taking a permutation of length 3 from the cars. Yep. It's not necessarily a set, exactly. So Because remember in a set, like the order of the elements doesn't matter and stuff like that. In a permutation, the order of the elements does matter. So it's a little bit different than that. But it's really, it's basically like I mean, think of a deck of cards. So when you shuffle a deck of cards, you're permuting the deck of cards, right? It's just taking a set of things and putting them in an order is all a permutation is. So an example of a permutation type question is, so you've got 9 people are lining up for a photo. Just left to right, so there's no second row or anything. So how many ways can they line up? Okay. So this is not really different from what we were doing before, right? If I say, how many ways can I choose the leftmost person? There's 9 ways. How many ways can I choose the next person? There's 8, 7, all the way down to 1. Which, so for this one, I actually wrote down the number. It's like 362, 880. Okay. Yep. Yeah, exactly. So that's actually what was about to do is introduce this notation. You've probably seen it before, though. So if I take a number, an integer like 9, and I multiply all the integers below it, or from 9 all the way down to 1, we call that a factorial. So yeah, 9 times 8 times 7, etc. So the notation would be, well, n factorial is the product of all integers from 1 to n. So in other words, this would be 9 factorial. One slightly weird case is 0 factorial, which looks like it maybe should be 0, but for sort of technical reasons, it's better to define it to be 1. So 0 factorial is 1. Yeah. That's a good question, yeah. So in this case, we were using all the elements, but you don't necessarily have to use all the elements. Yeah, that's the next example is going to be like that. That's exactly where we're going to go, yeah. Okay, so yeah, so this is just something to really remember. 0 factorial is not 0. It's 1. And also this is called, n factorial. It's not, you don't just say n really loudly, right, with an exclamation mark. Oh yeah, another thing is for computing these factorials, there is a button on your calculator for this. So you don't have to do 9 times 8, blah, blah, blah. Just press like, somewhere on there, there's a factorial button. So when you say 0 factorial is not equal to 0 factorial. Technically, it is equal to 0 factorial, factorial, yeah. Maybe I should just, yeah, for clarity. No, that's a good point. Okay, yeah, so let's address this question about whether you have to use all the elements in a permutation. So technically, in this definition of permutation, I didn't say you have to use all the elements. So this is kind of similar to this race car question, or the car race question. So 100 people are running a race. How many ways or how many possibilities are there for the first 9 finishers? And again, there's no ties. Okay, and this is, something we, quite similar to other questions we've done, right? You've got 100 choices for the first, 99 for the second, 98 for the third. Maybe I should keep track of these. So 1, first place, second place, third place, 4, 5, 6. Just so I don't go too far. So 97, 96, 95, 94, 93, and 92. Okay. Hopefully I got that right. Again, though, this would be like kind of unfortunate to like have to type all of this into your calculator. So one nice thing is you can kind of recognize that there's somewhat of a pattern here. Like, so this is not 100 factorial, obviously. We didn't go all the way down to 1, but it's part of 100 factorial, right? We went from 100 down to 92. What if I take, so what this really is it's like 100 factorial, except it doesn't go all the way down to 1. It stops at 92. But if you think about it, that's the same as dividing by 91 factorial. Because, so this is going to go all the way down, 100 factorial goes all the way down to 1. Right? So if I got 100, 99, dot, 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 down to, let's say, all right, 92, and then 91, 90, dot, 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 all the way down to 1. So I'm just kind of rewriting what I've written here. This one starts at 91 on the bottom, times 90, times dot, 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 down to 1. And you can see that all of this stuff will cancel. And you have 100 down to 92, which is what we're writing here. Okay. So in this case, if you can kind of work out that this is going to be your answer, you can just put that in your calculator. Yep. Yeah. That's probably true. It's probably too big for that. So probably, yeah, the types of questions you'll be given will probably be, I mean, this was just one I came up off the top of my head last night. They'll probably have more reasonable numbers so that you can actually put them in your calculator. But yeah, I imagine 100 factorial is way too big for this. But yeah. Oh, sorry? Yeah, so that's the notation. So yeah. So let me just kind of introduce that now. Oh, actually, so that, if you put 10p9 in your calculator, that works or it doesn't? Oh, it does work. Okay, so yeah. Okay, so we will have, there is a way to resolve this issue about the calculator. So I'll explain that now. So what we've done here is we have a set of size 100, we permuted 9 elements. We chose 9 elements and put them in order. So generally speaking, the number of ways to choose a permutation of R elements from a set of size n is n factorial over n minus r factorial. So the previous example, n was 100 and r was 9. So that's where this 100 factorial over 91 factorial came from. Okay. So what I mean by this, if you're asked to take a ordering of R elements from a set of size n, so permutation is just an ordering of elements. If your question says, how many ways can you basically order R elements from a set of size n, this is going to be your answer. Now, there is different notation for that, which is going to be convenient for your calculator. So other notation for this is sometimes it's written PNR. Like this. So this, I think this is what your textbook uses. Okay. So if you see this in your textbook, it means n factorial over n minus r factorial. Or in other words, it's the number of ways to permute R elements from a set of size n. And then in your calculator, it looks like this. Okay. So as was mentioned, so if you try to put that in your calculator, it gives you an error. However, if you try to put, so the 100p9, if you put that into your calculator, it actually works. Okay. It should give you a number. So you should see something on your calculator that looks like NPR. Yeah. Any questions about that? Yeah. Yeah, you have to do 100, yeah, and then hit this NPR button, I think, and then put 9 or something. Yeah. Okay, so let's try one more question. So let's say I have 20 math books. And let's say 14 other books. How many ways can we arrange the books on a shelf? So that's going to be the first part of the question. Oh, and all of these books are different. So there's no, I don't have two copies of the same book. So they're all different books. How many ways can I arrange them on a shelf? Okay, and then then after that, we'll do a more complicated version. So does anyone see the answer to the first one? Or maybe not the raw number, but something involving a factorial or something. Yeah. Yeah, exactly. So at this point, math books or other books, it doesn't matter, right? Because I'm just arranging them. I don't really care. So it's 34 factorial. What if I say, how many ways can I do it such that all the math books are on the left, all the other books are on the right? So what if I do it such that math books on the left, other are on the right? So I just mean put all the math books first, all the other books after that. Any thoughts about that? So we have to be very, this is where these things are always tricky because it's really hard to tell, should I be adding or should I be multiplying? I mean, every single one of these questions, you're going to have to ask yourself that. So this time we're going to multiply. Why? Because you can think of this as a two-step process, right? In my first step, I arrange all my math books. First step can be done in 20 factorial ways. In the second step, I arrange all the other books. That can be done in 14 factorial ways. So you should be multiplying these two numbers, right? Okay.